saya tak tulis tajuk kat sini. So chapter 2 adalah noise. Okay, so what we will cover in this chapter is, first, we are going to look at the type of noise. Okay, they have many types of noise. Okay, and then noise spectral density, then signal to noise ratio, SNR, then noise factor and noise figure, Friis formula, equivalent noise temperature, and noise measurement. Okay, so everything is based on noise. So, okay. Okay, kita tengok dekat sini, noise. Okay, so noise, we have two types of noise. Okay, if you look at this chart, we have a correlated noise and uncorrelated noise. Okay, so what is correlated noise? Correlated noise is if you have the signal, the noise only occur when they have a signal. Maksudnya bila ada signal baru ada noise. That is correlated noise. Okay, and different with uncorrelated noise. Okay, noise occur anytime, even there is no signal. Okay, maksudnya noise memang ada saja kat situ walaupun tak ada signal yang kita bagi pada sistem tersebut. Okay, that is uncorrelated noise. Okay, for uncorrelated noise, okay, they divided into two, external and internal noise. External maksudnya luaran, noise yang terjadi bahagian dekat bahagian luar. Okay, while internal is inside, kat dalaman. Macam kalau you ada circuit, so inside the circuit, we also have a noise. Okay, so for internal noise, kita ada short noise, transient time noise, and thermal noise. Okay, and for external noise, okay, noise yang ada dekat sekeliling kita. Okay, we have an atmospheric noise. Okay, atmosfera kita pun akan menghasilkan noise. Okay, and then the extraterrestrial noise, man-made noise is noise yang kita buat. Okay, macam enjin kereta. Okay, apa-apa saja yang kita producekan noise. Okay, and then the impulse noise, interference noise, and then for extraterrestrial we have solar noise and cosmic. Okay, this is all the uncorrelated noise. Uncorrelated noise, which means noise present all the time. Sepanjang masa dia ada noise. Okay, and this is the correlated noise. Okay, dia ada dua jenis. Okay, untuk correlated noise we have a harmonic distortion and intermodulation distortion. Okay, so this is the big pictures of noise. Okay, jenis-jenis noise yang ada, apa classification dia. Okay. Okay, so kita tengok dekat sini. Okay, tadi saya dah terangkan kan correlated noise. Correlated noise tu only exists when signal is present. Bila ada signal saja baru ada noise. Okay. Uncorrelated noise ni sepanjang masa dia ada. Okay. Okay, so kita tengok dekat sini. Untuk external noise adalah noise yang kita generate outside the device ataupun circuit. Okay, it's a surrounding noise. Okay. Dia ada 3 primary source yang akan contribute pada external noise, which is atmospheric, extraterrestrial, and man-made, macam saya cakap tadi. Okay, so what is atmospheric noise? Okay, you tengok dia punya tajuk ni pun you tahu kan atmosfera kan. Okay, so for atmospheric noise, okay, actually, okay, dekat kita punya atmosfera, okay, dia akan ada charge-charge dan particle-particles ni. Okay, so dia akan electrical disturbance, okay, at atmosfera bumi. Okay, dia akan berlaku electrical disturbance dekat situ. Okay, We call it static electricity. Okay, and most static electricity is naturally occurring electrical conditions such as lighting, lighting, lighting ke lightning. Okay, you are electric kuasa kan, power, so you dah familiar lah kan dengan kilat apa semua tu kan. Okay, so in the form of impulse, okay, this noise, okay, dia punya frequency insignificant at frequency above 30 MHz. Okay, ingat untuk atmosphera noise dia hanya berlaku pada lapisan atmosfera. Okay, dia ada static static dekat situ Okay, and then kita ada extraterrestrial noise. Okay, extraterrestrial noise dia adalah outside atmosphere. Dia di luar atmosfera bumi. Okay, kalau atmospheric tadi dia di lapisan atmosfera bumi. And this one is outside, di luar atmosfera bumi. Okay, dia di space kat sana. Okay, so dia ada dua jenis. One is a solar noise, satu lagi cosmic noise. Okay, so solar noise kita ada. Solar noise adalah disebabkan oleh daripada pemanasan matahari. Okay, so dia ada apa kat sini dia ada dua bahagian solar noise. Okay, satu adalah dia quiet condition when constant radiation intensity exists and high intensity, and then dia ada sporadic disturbance because of sunspot activities. Okay, and the solar flare-ups. Okay, yang mana dia berlaku setiap 11 tahun. Ini adalah aktiviti matahari. Okay, so and then yang kedua adalah cosmic noise. Okay, ini adalah noise yang disebabkan oleh galaksi dekat luar lah. Okay. Okay, kalau untuk atmospheric apa semua ni kita ada certain 2-3 orang pensyarah yang memang mengkaji bahagian-bahagian atmosferik ni. Okay. Kita ada Dr. Mariam, kita ada Dr. Abul, kita ada Dr. Jong. Okay, and also Dr. Katigesu. Okay. So, diorang memang study on this lapisan-lapisan atmosfera bumi ni lah. Okay. Okay, and then man-made noise. Okay, noise yang kita hasilkan, manusia hasilkan. Okay, so anything yang kita hasilkan macam bunyi kereta, okay, and then kilang-kilang pun kadang-kadang dia ada noise kan. So that one is a man-made noise. Okay, and then dia lebih kepada industrial noise. Okay, kalau dekat kawasan industri. Okay. Okay, and next is a impulse noise. Okay, so impulse noise ni biasanya dia daripada electromechanical switch ataupun electric motor. Okay. Okay, and then kita ada interference. Okay, so interference ni adalah dalam bahasa Melayu ni adalah gangguan. Betul Interference, interfere, ganggu. Okay, interference is a signal which is come from one source that interfere with another signal. You have signal A, but then you have another signal that interfere with your signal. Okay, so it will occur when the harmonics or cross product frequency from one source fall into the pass band of the neighboring channel. Okay, so nanti kita tengok what is a harmonic and cross product frequency. Okay. Okay, and then this is the internal noise. Okay, previously is the external noise and now is the internal noise that generate within the circuit ataupun device. Dia hanya ada dalam circuit dan device saja, dia tak ada kat luar. Okay, so we have 3 types of internal noise. Okay, we have short noise, transient time noise and thermal noise. Okay, so what is short noise? Okay, so short noise disebabkan oleh random arrival of carriers. Okay, carriers ni sama ada hole atau elektron. Hole atau elektron is a charge positive ataupun negative. Okay, it's caused by a random arrival of carrier at the output element of an electronic device such as diode, field effect transistor, FET, or bipolar transistor. Okay. Okay, so this is a short noise. Okay, sometimes kita panggil dia transistor noise. Okay. Okay, the next one is a transit time noise. Okay, transit time noise is any modification to a stream of carrier as they pass from input to output of a device and they produce irregular ataupun random variation. Okay, and the time it takes for a carrier to propagate through a device is appreciable part of the time one cycle of the signal and the noise become noticeable. Okay, so ini you just baca je . Okay, if transmit delays are excessive at higher frequency, the device may add more noise than amplifications of the signal. Okay. Okay, last one is a thermal noise. Okay, thermal noise happen because of a rapid and random movement of electron. Kita ada elektron dalam circuit. So bila elektron ni bergerak secara rawak, okay, dalam konduktor tu, okay, dia akan menyebabkan thermal noise. Dia akan ada because the electron bila dia move, okay, so itu adalah thermal noise. Okay, dan dia memang ada dalam setiap electronic component. Okay, sebab elektronik dia adalah terbentuk, electronic component dia terbentuk daripada elektron-elektron ni. Okay, so memang ada. Okay. Okay. Thermal noise ni, sometimes kita refer dia sebagai white noise. Okay. Okay, kalau additive noise, okay, meaning that it cannot be eliminated. Kita tak boleh nak eliminate noise, okay, dalam circuit. Okay, and it increase in intensity with the number of device and circuit length. Maksudnya kalau kita tambah lagi kita punya komponen elektronik, okay, so the noise will be increased as we increase the component. Okay. Okay, faham Ini secara general, ini teori je. Okay, belum masuk calculation lagi. Okay, so this one is a noise spectral density. Okay, in a communication, okay, noise spectral density kita panggil dia sebagai N0. Okay, so N0 is noise spectral density, which is the noise power per unit bandwidth. Which means we have a bandwidth, one bandwidth, okay, then the power for that bandwidth is equivalent to N0 or noise spectral density. Okay. Okay, unit dia adalah dalam watts per hertz. Kenapa watts per hertz? Noise is watt, we measure, the unit is watt, and bandwidth is hertz. Okay, and this one is actually equivalent to watts, second, or joules. Okay. Okay, kalau if the noise is white, kalau noise itu adalah noise, white noise, okay. If white noise, okay, frequency is constant, then the total power and in bandwidth is B and not. Okay, kalau white noise, okay, the total power, okay, the total noise power is equivalent to B and not. Okay, so B is a bandwidth, N naught is this one. N naught is a thermal noise density. Okay, thermal noise density is N naught. N naught is equals to K times T. Okay, K is a Boltzmann constant. Okay, and T is temperature in Kelvin. Okay, remember temperature in Kelvin. If you have temperature in degree Celsius, you have to convert it to Kelvin. Okay, N naught. Okay, N naught usually we use to do the link budget. Okay, for example, you want to get the EB over N naught or ES over N naught. Okay, later we will look what is EB over N naught, what is ES over N naught. Okay, so make sure you know that N naught is KT. Okay, KT means Boltzmann constant times with T. Okay, ada soalan tak untuk ni? Tak ada. Okay, kalau tak ada, kita move to noise power. Okay, so noise power Pn. Okay, so Pn is we integrate from minus B to B. Okay, minus B, and B is a bandwidth. Okay, N naught over 2 dF. Okay, we integrate this one, and then we get a Pn equals to N naught times B. Okay, you don't have to do the integrations. You just use Pn equals to N naught B. That's it. Okay, just remember this one. Okay, noise power equals to N naught times B. So what is N naught? We know that N naught equals to KT. Okay, N naught is KT. Okay, kita masukkan dekat rumus ni. Then we get Pn equals to KTB. So noise power equals to K darabkan dengan T darabkan dengan B. So what is K? K is Boltzmann constant. T is temperature in Kelvin. B is bandwidth in Hertz. Okay, and K, what is the value of Boltzmann constant is 1.38 times 10 power minus 23. Okay? Okay? Faham?
Okay.
Okay. Okay, then okay, dekat sini dia kata, it is clear that power spectral density of thermal noise increase with increasing the ambient temperature. Maksudnya kalau you tengok dekat rumus ni kan, Pn equals to KTB. If your temperature is increased, your P also increase. Betul? Your noise power also increase. Betul tak? Betul? From these equations, daripada rumus ni, we can see that if your T is increased, then your noise power also increase. Betul tak?
Betul, Doktor.
Betul kan? Noise power is directly proportional to your T. Kan? Okay, then kalau kita nak kurangkan, if you want to decrease the noise power here, what we should do with the temperature, we have to make the device cool. Betul tak? Kita kena kurangkan dia punya kepanasan dalam circuit tu. Then we can reduce Pn. Okay? Okay. Okay, diam tanda setuju Okay, next kita tengok noise voltage. Banyak noise ni sebenarnya kan? Okay. Okay, noise voltage, okay, dia akan occur dalam kita punya circuit. Okay. So, look at this circuit. Okay. We have a source here, Vn, And we have R1 and R here. Okay. This R1 and R is we connected as a series. Kita sambung dia secara series kan. Therefore, V for R1 is Vn over 2 and this one Vn over 2. Okay. Ini kalau R1 dengan R2 ni sama. Kalau sama baru kita boleh bahagi 2. Kalau tak sama tak boleh bahagi 2 Okay. Kalau tak sama you kena kira dia punya voltage dia. Okay. Okay, so we have here internal resistor R1. Okay. And then it stated that for the worst condition, okay, the load resistance, this is the load resistance is equals to the internal resistance here. R equals to R1 here. Okay. Then Vn, so voltage here will be Vn divided by 2. It's a half. Ini sama kan? Bila sama, voltage dia bahagi separuh. Separuh sini, separuh sini. Kan? Contoh katalah awak ada Vn sama juga dengan 10 volt.
Macam mana kau suruh buka kamera?
Habis lah su. Buka kamera
And
kat
then
muka orang lain.
Ni kat Indonesia peti apa ni?
Ri equals to berapa volt? 2 ohm. R equals to 2 ohm juga. Okay. Kita ambil worst case R sama dengan R1. Okay. Then voltage dekat sini akan jadi Vn bahagi 2. So sini 5, sini 5. Total voltage dekat sini adalah 10. VR1 tambah VR sini dia akan jadi sama dengan Vn. Okay. Ini untuk worst case. Okay. Then the noise power Pn. Okay. Pn tadi kita dah kira tadi kan. Dah tengok kat sini. Pn ni. Okay. So noise power Pn. Okay. Develop across the load resistor. Okay. So Pn yang develop dekat load resistor ni adalah KTB. Okay. Pn sama juga dengan KTB. Okay. Then Pn sama juga dengan Pn dekat sini kan. Pn dekat load dia cakap across the load resistor. So here. This is load resistor. So kita tahu P sama juga dengan IR, betul? Betul? Salah ni, bukan IR. P sama juga dengan IV. Betul? Kan?
Betul.
Betul Ataupun sama juga dengan V square over R ataupun I square R. Right? So depends apa yang kita ada. So in this case we have V, voltage and resistor. So kita pakai yang ni. Okay? So Pn is voltage, okay? Vn, P dekat sini, Vn over 2 square divided by R, this R, okay? And equals to Vn square divided by 4 divided by R and equals to Vn square divided by 4R. Then we get Pn equals to Vn square over 4R. Okay, yang ini faham tak? Faham Okay, we have Pn. Okay, Pn equals. Okay, thank you. Pn, macam mana saya nak tulis ni? Okay, now we want to get Vn. Okay, nak dapatkan Vn, kita rearrange back this equation. Okay, so we have Vn square equals to Pn for R. Right? Kan, kita naikkan for R ni dekat sini. Okay, Then we get Vn square. Vn equals to Pn for R square root. Right. Good. Okay, so what is Pn? Pn adalah KTB. Kita masukkan KTB inside this equation. Then we have Vn equals to Pn is KTB for R. Oops. Okay. Okay. Okay, diam ni saya assume okay. So Vn equals to square root KTB for R. Ataupun you boleh susun balik lah jadi cantik macam ni. For R KTB. Mana-mana pun tak apa. Okay. Okay, kita tengok example 2.2. Okay. Calculate the thermal noise power available from any resistor at room temperature 290 Kelvin for a bandwidth of 1 MHz. Calculate also the corresponding noise voltage given that R equals to 50 ohm. Okay. So dia kata dia nak calculate the thermal noise power. Thermal noise power adalah Pn. Right. Okay. Available from any resistor at room temperature. Okay. Dia nak Pn. And then the given here is the T equals to 290 Kelvin and bandwidth equals to 1 megahertz. Okay. And also calculate the corresponding noise voltage. Noise voltage is Bn. Okay. And also the given here R equals to 50 ohm. Okay, kita nak cari Pn and Vn. Okay, first you dapatkan Pn. Okay, Pn equals to KTB. This one. Okay. Okay, so Pn equals to KTB. K is Boltzmann constant 1.38 times 10 power minus 23 times with T 290 Kelvin and times with bandwidth 1 megahertz. Okay. Then you get Pn equals to 4 times 10 power minus 15 watt. Okay. Kalau you ada calculator, you boleh terus kira. You dapat this one. Okay. Okay, we have Pn. Now we can get Vn. Okay, noise voltage. Okay, noise voltage, we know that the equation is square root PR KTB. KTB we already calculate here. Okay, so Vn equals to square root 4 times R 50 ohm times Pn 4 times 10 minus 50. Then you get Vn equals to this. Okay. Okay.
Boleh, doktor.
Boleh. Okay. Okay, next example is, okay, you have an electronic device operating at temperature 70 Celsius with a bandwidth of 10 kilohertz. Then you have to determine the thermal noise power, okay, Pn, in watts and dBm. Okay, kat sini dia dah statekan dia nak in watts and dBm. Okay, and then you have to determine the noise, RMS noise voltage for internal resistance 100 ohm and the load resistance 100 ohm. Okay. Kat sini temperature dibagi in Celsius. Okay, bandwidth 10 kilohertz. So in Celsius, you have to convert to Kelvin. 70 degrees Celsius is equivalent to 290 Kelvin. Okay. Okay, next is Pn. Okay, Pn is KTB. This is K, this is T, this is B. Okay, then you get Pn here in watt. Okay, you have to convert to dBm. Okay, so 10 log 4 times 10 minus 17 divided by 1 milliwatt. Then you get minus 134 dBm. Okay. Okay. Faham senang kan? Very direct Then next is you have to determine the noise voltage, Vn. Sama juga, sangat direct. So Vn equals to this equation. This one, we already calculate here. Okay. Then you just masukkan je nilai R yang diberi ni. Then you dapat. Okay. Okay. Masuk nilai je kan? Okay. This one. This one tak ada jawapan kan? Oh ada juga. Okay. So next example is, okay, you have two resistors, 20 kilo ohms and 50 kilo ohms. Both are at room temperature 290 Kelvin. Okay, for a bandwidth of 100 kilohertz. Okay, what you need to calculate is a thermal noise voltage, Vn. You have to determine Vn. Okay, Vn, okay, generated by each resistor, and then Vn generated by two resistors in series, and the last one is Vn generated by two resistors in parallel. Okay, we know that Vn equals to 4RKTB. Okay. Okay, so tengok dekat sini what the information given is okay, you have R1 equals to 20 kilo ohms, R2 equals to 50 kilo ohms, and you have a temperature equals to 290 Kelvin, and a bandwidth equals to 100 kilohertz. Okay. Okay.
Okay,
Okay,
doktor.
so boleh kan buat kan? Okay, nak senang you cari dulu yang ini KTB ni. Nanti you plug in je. Okay, you get Pn equals to KTB, which is equals to 1.38 times 10 minus 23 times 290 times 100. Okay, so berapa nilai awak dapat? 1.38 kali 23 kali 290 kali 100. Awak dapat 4 kali 10 negatif 16. Betul tak? Betul tak? Saya tengok kat sini lah betul tak jawapannya. Oh, dia tak kira PN, dia kira macam ni Okay. Okay, you dapat P. Betul 4 kali 10 negatif 16. Okay, next is untuk each resistor. So Vn untuk setiap resistor is, okay, untuk R1. R1 awak equals to 2 kilo, 20 kilo ohms. Then Vn equals to 4 kali 20 kali 10 kuasa 3 kali dengan 4 kali 10 negatif 16. Square root kan. Okay, then you dapat 4 kali 290 kali Betul. 681 kali 10 negatif 9 watt. Tak sama. Saya salah kat mana ni? Saya salah tekan kalkulator ke? Okay.
Ia dapat sama dengan jawapan, Doktor.
Ya, kenapa saya dapat lain?
5.6. Sama, Doktor.
3 kali 1.38. Okey, saya salah tekan. Betul lah, sama. Dia lari sikit-sikit je. Lima, 65. Okey. Okey, ini untuk R1. Untuk R2 sama juga. Okey, R2 adalah 50 kilo ohms. Okey. So, saya tak payah tulis. Saya ikut kat sini je lah, senang. Okey, 50 kilo ohms. 4 darab 50 kilo ohms darab dengan Boltzmann constant, darabkan dengan T, darabkan dengan B. Then you dapat this one. Dapat sama tak? Square root 4 kali 50 kilo kali 4 kali negatif 16. 8.94. Okey, 8.94 kali 10 negatif 6 volt. Okey. Ada tak yang tak dapat? Tak ada, semua dapat Okey, next. Soalan dia kata, kalau kita sambung two resistor secara sesiri. Okey, secara sesiri tu maksudnya you sambung macam ni kan? R1, R2. Okey. So, kalau macam ni, awak tambahkan je total resistor RT equals to R1 tambah R2, which is sama dengan 20K plus 50K equals to 70 kilo ohms. Okay. So, you ambil total RT here, masukkan dekat sini. Okay. Then, VN equals to 4 darabkan dengan RT awak 70 kilo ohms, darabkan dengan PN awak yang ni. Then you dapat 1.06 times 10 minus 5 volt. Okay.
Okey, Doktor.
Okay. Okay, next is soalan ni dia kata, two resistor kita sambungkan secara parallel ataupun secara selari. Selari maksudnya? Maksudnya, you sambung macam mana saya nak lukis Okay. R1, R2. Then RT is R1. Okay. Satu bagi 20 K plus B. Satu bagi 20 kilo plus with 1 bagi 50 kilo ohm. Okay, then you dapat 14.29 kilo ohm. Okay, faham macam mana dapat macam ni? Okay, ini kalau dalam selari, okay, RT awak akan jadi RT equals to 1 per R1 tambah 1 per R2, then you inversekan dia. Okay, ataupun sama juga dengan R1 R2 per R1 tambah R2. Okay, dapat RT. 70 kilo ohms times 20 kilo ohms divide by 20 kat mana ni? 50. Okay, so this one is 50. Okay, divide by 20 tambah 70, 20 tambah 50, 70 kilo ohm. Okay, dapat tak 14.29?
Dapat doktor.
Dapat kan? Okay. Okay, so you dah dapat RT here. You masukkan terus kat dalam sini saja. Okay. So Vn equals to 4 kali RT 14.29K times KTB. Then you dapat Vn. Okay. Ada soalan? Tak ada.
Doktor,
Okay,
doktor.
kalau tak ada, kita masuk dekat correlated noise.
Tak ada.
Okay, so correlated noise, okay, actually dia hanya ada bila ada signal baru noise tu ada. Kalau tak ada signal, so tak adalah noise ni. Okay, so macam mana dia berlaku correlated noise ni adalah disebabkan non-linear amplification. Okay, ataupun non-linear distortion. Okay, then kita akan ada harmonic distortion and intermodulation distortion. Okay, apa itu harmonic distortion? Okay, harmonic distortion adalah any unwanted harmonics of a signal that produced through non-linear amplification ataupun non-linear mixing or any non-linear punya operation. Okay, so harmonics adalah integer multiples of the original signal. Maksudnya kita ada original signal satu, okay, but because of the non-linear amplifications ataupun any non-linear operation, okay, another harmonic will be introduced. Kita akan ada banyak multiples of harmonic. Okay. Okay, kita ada sebenarnya various degree of harmonic because we have multiples of harmonic produced by non-linear operation tadi kan. Kita ada second order, third order, kita boleh sampai n order of harmonic distortion. Okay. Okay, so kalau kita ada second order harmonic, okay. Here, untuk second order, okay, the ratio of the RMS amplitude of the second harmonic, okay, second harmonic to the fundamental amplitude. Okay, kalau third order, kita ambil ratio untuk third harmonic kepada fundamental amplitude. Kalau n order, maksudnya kita ambil pada, if we have n order, okay, then the ratio is untuk n harmonic divide by fundamental amplitude. Okay. And the total harmonic distortion, THD, is a ratio of quadratic sum of RMS value of all the highest harmonic to the fundamental. Kita tengok kejap lagi dia punya rumus. Tapi sebelum tu kita tengok ni dulu. Okay, so harmonic distortion adalah contoh dia yang ini. Okay, ini you boleh tengok daripada spectrum analyzer. Okay, so spectrum analyzer kita tengok frequency. Okay, ini adalah kita punya signal kita, main signal kita. Okay, and dalam spektrum tu sendiri kita ada kita punya circuit apa semua tu kan. And then kita punya circuit tu pun kita punya circuit yang kita nak measure tu pun dia ada operation dekat situ. Okay, so because of that this multiple harmonic is introduced. Ini kita tak nak pun, tapi dia ada. Okay, so ini adalah unwanted signal yang ada dekat dalam kita punya signal. Instead of the original, we have this multiple harmonic kat sini. Okay. Okay, so tengok dekat sini yang bahagian A. Okay, so harmonic distortion yang atas ni. Okay, kita ada input signal kita satu ni saja, F1 saja, and dia punya amplitude dia V1. Okay, but then bila dia ada non-linear operation, okay, multiple harmonic will be introduced here. Okay, so you will have V2, V3, V4 and so on. And also the frequency also, you have a fundamental frequency F1, and then you have multiple frequency, okay, for multiple harmonic here. Here you have 2F1, 3F1, 4F1 and so on. Okay. And the total harmonic distortion here, THD, is equals to V higher which means this V, okay, divide by V fundamental, this one. And then times with 100. Okay, so V higher adalah quadratic sum of this one. You have V2 square plus V3 square plus V4 square until Vn square. Okay, so this is the V higher. Okay, divide by V fundamental, this one, V1. So this is how we get the total harmonic distortion. Okay. Okay, faham yang ni? Okay. Next is intermodulation distortion. It's a difference between harmonic distortion and intermodulation distortion. Okay, intermodulation distortions is a generations of unwanted some and different frequency. Okay, bila two or more signal are amplified in a non-linear device. Okay, this one intermodulation distortion if you have two or more signal, then the signal will be sum or difference between these two signal. That we call intermodulation distortion. Okay, the difference and the sum of the frequencies we call as a cross product. Okay, if you look here, 2.7b, okay, this is the intermodulation distortion. Okay, you have these two signal is the input signal, F1 and F2. Okay, and the voltage is V1, V2. Okay, these two signal, okay, will produce the sum and difference. You will have a sum F1 plus F2, and the difference is F1 minus F2. You have these two signal produced from these two input signal. This is intermodulation distortion. The sum and different frequency, okay, here you have sum frequency and difference frequency. We call it a cross product. Okay, so cross product is M F1 plus minus N F2. Okay, plus minus because we have sum and difference, right? Plus for sum and minus for difference frequency. Okay, and for the this one, if you are using this one, you must set F1 higher than F2. Okay, it doesn't matter, but F1 must be higher than F2. Okay, and M and N is a positive integer. It must be M and N here is a positive between 1 and infinity. It cannot be negative or nombor perpuluhan. Faham? Okay, we have here, okay, how does intermodulation distortion occur? You have this red and blue is the what? Is the original signals, okay, F1 and F2. You have the cross product. Okay, you will have the, where is it? Okay, here is the sum. Okay, F1 plus F2, F2 minus F1. This is one pair. Okay, then you will have also the here 2F2 minus F1, 2F1 minus F2. Okay, and also you will have here and here. You will have multiples of harmonics. Okay, faham tak ni? Okay, nanti kita tengok lagi ya. Okay, tengok contoh ni. This one for harmonic distortion. Okay, example 2.5 is a harmonic distortion punya example harmonic distortion. Okay, so determine the second, third and 12th harmonic for a 1 kilohertz repetitive wave, which means your fundamental frequency is 1 kilohertz. Okay. Next is you have to determine the percent second order, third order and total harmonic distortion for a fundamental frequency with an amplitude. Okay. So V1 awak equals to 8 voltage. Okay. A second harmonic, okay, amplitude dia yang ini. So V2 equals to 0.2 V and the third harmonic is okay. Okay, so untuk dapatkan harmonic second, third and 12. Untuk second, you just darabkan 2 darabkan dengan fundamental frequency tadi. Fundamental frequency awak 1 kHz. Okay. So 2 times 1 you get 2 kHz for second harmonic. Third harmonic is 3 darab 1 kHz, you get 3 kHz. 12 harmonic jadi 12 kali fundamental frequency 1 kHz, then you get 12 kHz. Okay. Ada soalan tak? Sebab tadi kalau you tengok dekat graf ni,
Sekali.
dekat graf ni kan, mana tadi? Okay. Ini F fundamental awak F1. So, second order 2 kali dengan F1. Untuk third order 3 kali F1. Untuk fourth order 4 kali F1. Untuk nth order is n kali F1. Okay? Here. Okay. So, ini tak ada masalah kan? Boleh faham Okay, next is you nak dapatkan percent order. Okay, percent order kalau you tengok dekat dia punya explanation tadi. Okay, second order adalah ratio antara mana tadi? second harmonic punya amplitude, okay, bahagikan dengan fundamental amplitude. Maksudnya, untuk second order, V2 bahagikan dengan V fundamental ataupun V1. Okay. Untuk third order is V3 bahagikan dengan V fundamental. Untuk Vn, sama je. Okay. Then this one will become, okay, for second order, okay, V2 divided by V1. V1 is your fundamental amplitude. V2 is the amplitude for second order, second harmonic. Okay. Then, dekat sini dibagi, it's given here for second harmonic is 0.2. Then 0.2 divided by 8 times with 100, you get percentage here. Sama juga dengan untuk third order, voltage untuk third order divide by fundamental voltage, darabkan dengan 100, then you get the percentage. Okay. And the last one is a total harmonic distortion. Total harmonic distortion is a V higher. So what? V higher divide by V fundamental. Okay. So V higher adalah equals to V2 square plus V3 square root. Okay. So that's why you get this one. Okay. Okay. So you dapatkan V higher divide with V fundamental and then you times 100, you get this percent of total harmonic distortion. Okay. Ada soalan?
Doktor, V
Yes.
higher bahagi dengan V1
V1. V1. V1 ataupun kita panggil dia V fundamental.
Okay.
Okay, sometimes soalan dia bagi V fundamental kan. Sometimes dia tulis V1. So dia benda yang sama. Okay. Ada soalan lagi? Okay, kita tengok. Okay, ini example lah sebelum saya stop. Okay. Dah 10.45 kan. Okay, last example untuk hari ni. For a non-linear amplifier with two input frequency 3 kHz and 8 kHz. Okay, so this one is intermodulation distortion, ID. Okay, intermodulation distortion adalah you have this one, okay, F1 and F2. Okay, so F1 and F2 is 3 kHz and 8 kHz. Okay, determine first three harmonic present in the output for each input frequency. Dia nak you dapatkan 3 harmonik pertama yang ada pada bahagian keluaran untuk setiap input frequency. Okay, and then dia nak awak dapatkan cross product frequency untuk M and N 1 and 2, which means M equals to 1, N equals to 2. Okay. Okay. Okay, first three harmonic. Okay, untuk F1. F1 is 8 kHz, okay. So F1 is 8 kHz, F2 is 3 kHz. Okay, so first three harmonic adalah, harmonic yang pertama adalah original signal kita. Okay, betul tak? You ada original signal here, F1. Okay, and then you have second harmonic, 2F1. Third harmonic is 3F1. Okay, so first harmonic is your fundamental frequency, 3 kHz. Second harmonic is 2 times 3, 6 kHz. Third harmonic is 3 times 3, which is 9 kHz. This is for 3 kHz. If you have 8 kHz, sama juga. First harmonic will be your original frequency, 8 kHz. Second harmonic is 8 times 2, 16 kilohertz. Third harmonics is 3 times 8, you get 24 kilohertz. Okay. Okay. Faham Okay.
Okay,
And
doktor.
last one is the cross product. Okay. So cross product here, okay, dia kata M and N of 1 and 2. Okay. Okay, you boleh buat macam ni. Okay, you boleh buat kotak ni. Okay, so the cross product will be M and N. So it can be either both M and N is 1. Okay, sama ada M1 and 2 ataupun M2 and 1 ataupun kedua-duanya 2. So what is the cross product yang terhasil kat sini? Okay, so let's say kalau M dengan N, M1 and 1. Then the cross product will be 8 plus minus 3, betul? Kan? Cross product is equals to M F1 plus minus N F2. Right. Okay. Dan F1 awak mesti lagi besar daripada F2. Okay. So here, kalau M1 N1, it will be 8. Dia akan jadi 8 plus minus 3. Kan? Betul? Betul tak? So, dia boleh jadi 8 plus 3, dia akan jadi 11 kHz ataupun 5 kHz. Okay. Untuk M1 N1. Kalau M1 N2, dia akan jadi M1 dia akan jadi 8 plus minus N2 2 kali dengan 2 kali dengan 3 dia akan jadi 6. So 8 kHz plus minus 6 kHz. So ya, dia saya. Ya,
Doktor macam mana dapat 5 kHz?
5 kHz 8 tolak 3.
Oh,
Dia
okey
ada.
okey.
8 plus
Okey.
minus 3 kan? So dia ada 2. 1 8 tambah 3, 8 tolak 3 dapat 5. Okay. Sama juga dengan yang ini. Kalau M1 dia akan
Okey,
jadi
doktor.
8 plus minus dengan N2. So 2 darabkan dengan 3 kHz. So you dapat 6 kHz here. Okay, kat sini. Okay, 8 tambah 6 kHz you dapat 14 kHz. 8 kHz tolak 6 kHz you akan dapat 2 kHz. Okay. Ataupun, okay, M awak sama juga dengan 2. N awak sama juga dengan 1. Okay. So kalau M sama juga dengan 2. So 2 kali F1, 2 kali F1, F1 8 kHz. Okay. So 2 kali 8, 16 kHz. Plus minus dengan N1. So 1 kali 3, 3 kHz. Okay. So kita ada 16 plus minus 3. Okay. So 16 kHz tambah 3 kHz you dapat 19 kHz. 16 kHz tolak 3 kHz you dapat 13 kHz. Okay. And the last one, kalau M awak 2, N awak pun 2. Okay. Then you will get 16 kHz plus minus dengan 2 kali 3, 6 kHz. Okay. So 16 kHz plus 6 kHz, you get 22 kHz. 16 tolak 6, 10 kHz. Okay. Faham?
Faham, doktor.
Faham tak? Okay. Kalau you tengok dekat sini, ini yang menyebabkan kita ada multiples of harmonic dekat sini. Nampak tak ni? Kan? Dia ada F2 minus F1, 2 F1 minus F2, 2 F2 minus F1, F mana ni? Nampak tak? Sebab tu kita ada multiples of ni. Okay? Okay. Ada soalan? Tak ada? Okay, kalau tak ada, kita jumpa
Okey, boleh,
next
Doktor.
week. Okay?
Tak ada.
Okay, so thank you sebab dapat bangun pagi pukul 8 join kelas saya.
Thank you, Doktor.
Okay.